Hi YouTube, this is my latest completely useless radiation detector. It's yet another ion chamber. This one's an integrating ion chamber. You can see here. It clicks. It's not a Geiger counter though. Each of these clicks is a discharge of the ion chamber. The ion chamber is basically a capacitor. When the ions pass through here, they cause leakage of the capacitor into the gate of the FET. The source voltage rises as the gate charges up, and this eventually reaches a point where the emitter base junction of this PNP transistor is forward biased. The base voltage is basically set to the top of the triangle wave, the sawtooth wave that you want the transistor to switch at. So as soon as this becomes forward biased, it then dumps the voltage here through this transistor's emitter and pulls down the bias on the can and the rest of the circuit all at once. This is kind of like those old-fashioned LED flasher circuits. It's a complementary pair basically. You've got PNP, NPN. As soon as there's any kind of current, collector current for the PNP, it will turn on the NPN, and that will provide the emitter the base current required to turn on the PNP even harder. So the whole thing saturates very quickly and discharges the emitter capacitance here through the two bases down to about 1.2 volts or something. When the entire thing stabilizes and cuts off, the voltage across this piezo is removed very quickly, so there's a nice click, and then the circuit will then charge back up once it recovers, and the voltage on the gate here has been discharged through the gate diode, the gate source diode, which is a little unconventional, and but at these currents it's not a problem. The capacitance here is quite small, and the peak current's very tiny. It's well within the allowed current of the gate source junction. This transistor is a little special. This is a PN4117A, which is a very low leakage electrometer JFET. The circuit does work just fine with other JFETs, but that particular JFET works very, very well as long as you keep the contamination of the gate to a minimum. Inside the actual ion chamber here, you can see the gate lead. I soldered a little bit of wire to it, and it's just poking up into the ion chamber. Focus up, damn you. There we go. The transistor's there. It's glued down to the board very carefully so that it didn't contaminate its gate lead. This is the Cermet trimmer that's setting the base voltage of the PNP for the switching point. We've just got one of these Kyocera piezos for the clicking. As you can see, it's clicking away here. It clicks every 20 seconds or so with just the background radiation and leakage. I might have contaminated the gate a little bit more than I wanted. With a bit of cleaning with some alcohol will help there. But yeah, very simple circuit, pretty useless. If this thing ever starts clicking more than a few times every 10 seconds, then you should probably run. Combustion ions will also make it click, as you can see the dark spot here where I accidentally hit it with the torch when I was trying this. Actually, let's try that now. 1 second. Somewhere over here on the junk heap we have, there it is, torch. I have absolutely no idea how this, what this circuit could be useful for, apart from perhaps X-ray detector. I actually tried an X-ray beam with it, and it didn't seem to be very linear. It didn't quite work the way I wanted. But for strong alpha sources like the americium source, it does work quite well. But again, yeah, if you ever hear it doing that, you're probably in big trouble and should get the hell out of the room and maybe out of the state. Anyway, yep, this was meant to be a quickie. It's now gone on for 5 minutes, so I'm going to shut up. Bye.